Hello everyone, this is PM Chalapandi here. First of all, I would like to welcome you to my today's session. In this session, we are going to solve another problem by using the same mathematical induction method. So let me dive into solving this problem. So here, our task is we want to show this series is equal to n is divided by n plus 1, which means this is a proposition, right? A mathematical proposition. So here we want to show that this proposition is true for all the natural number or not. So in order to prove that, so we are going to take one of the best mathematical method to show this, that is called induction method, mathematical induction method. So this method is helping us to solve this problem, which means this method is helping us to prove the given proposition is true for all the natural numbers. So there will be three steps, that three conditions that we need to satisfy in this method, right? In step 1, we have to show that the given proposition is true for the natural number 1. In step 2, we have to show that this is true for the natural number, true for k. In step 3, we will be proving this is true for k plus 1, right? So let me write the given proposition by the name p of n, right? So the whole proposition has written in the name of p of n. Next, step 1. In step 1, we want to show this proposition is true for 1, which means you have to take the nth term in both sides. That is true for the natural number 1, that we want to show that, right? So here what is left hand side nth term? It is 1 is divided by n into n plus 1. So here when you substitute n is equal to 1, your answer will be 1 by 2, right? So now let me write what we have in the right hand side. So it is n is divided by n plus 1. Now we have to check this with the same value to right hand side too. So the answer will be 1 by 2, right? So both answers are equal. Therefore we are satisfying p of 1 is true, right? So okay, let me move to step 2. In step 2, we are going to assume this proposition is true for the value k. Here we are not showing this is true for the value k. Instead of showing here, what we are doing is we are just assuming, because the assumed result is helping us to prove the next step, because that is very important. A proposition which is satisfying the last condition, that is condition 3, which is true for k plus 1, that proposition is true for all the natural number, right? So that is why we are just assuming a proposition is true for the natural number k, okay? Which means you just have to write the given proposition in terms of k, that is enough, right? So wherever you have n, that can be replaced by the name k, right? So after replacing by the name k, now your current proposition is this one. You just keep this result here itself. We will take this result in the next step. Let me come to the next step number 3. So here we want to show our proposition is true for p of k plus 1, right? So to prove this, first let me write the given proposition in terms of k plus 1, right? So which means this is in terms of k, the same proposition we have to write in terms of k plus 1, right? So which means we just write the proposition as it is. Now let me come here. Here we have k, that has to be replaced by k plus 1. So here I have replaced k plus 1. Here k can be replaced by k plus 1. Then we have already a 1. So when we add 1 plus 1, it is k plus 2, right? At the same time, we have to replace our right hand side also by k plus 1. So what is our value? K can be replaced by k plus 1, and k plus 1 is k plus 2, right? Now from this step onwards, our process is starting. So the same step has to write in the next step by including the previous step to the last step, right? So this is our last step. We have to write what is the previous step to this last step in the next step, right? Okay, first let me start as it is. Let me start with the as it is value. So 1 by 1.2 plus 1 by 2.3 plus etc. plus here the term the term before this to this last term is 1 by k into k plus 1. Then write the last term. Now you just club the from starting to till this step, because look at here, to this series we have a result in the previous step. The result is this one, that I'm going to substitute here, right? So instead of this series, I can substitute this result. So I just have substituted k by k plus 1. Now my task is I want to simplify this expression, and also I want to prove this result. If I am able to prove, then this is true for this k plus 1 is true for this proposition. If I am not able to prove this one, then this proposition is not a valid proposition for all the natural number, right? So let me try to prove. So here 1 by k plus 1 and 1 by k plus 1 we have in both terms, so that can be taken outside, right? So after taking outside, your rest of the terms will be k plus 1 by k plus 2, right? So here, so you just take LCM inside the bracket, which means take cross multiplication and write it. So when you take cross multiplication, it becomes k square plus 2k plus 1, right? And is divided by the whole value. This is the LCM rule. By using that rule, I just have done this process. Understand? Now, this is a quadratic equation. So we want to factorize this one, right? So when you factorize this one, your answer will be k plus 1, k plus 1. So we have a k plus 1 in the numerator here. So both answers are same. So that can be cancelled, right? The rest of the term is what? It is k plus 1 divided by k plus 2. This is what we want to show in the right hand side, right? So successfully we have proved this is true for k plus 1. Therefore, right hand side answer we got. So this is true for k plus 1. So this is the way to check whether your given statement is true for all the natural number or not. So dear student, your mathematical induction method is helping you to check your proposition or statement is true for all the natural number or any other that you want to check with other way numbers. That also you can check by help of this induction method, mathematical induction method. So I hope you all have understood about this how to solve this problem is clearly. So thank you so much by watching this video. So I will meet you with different problem in the next video. Thank you so much.